Hello, let's continue our Sudoku adventure with Europe by ZegreS. So this is a premiere for ZegreS for the Sudoku adventure series, so welcome, welcome. Let's go over the rules to this puzzle. So we have normal 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these blue lines in the grid. These are region sum lines. So what we do is we split up the line. I'm just going to use colors to split it here. We split it up by which box it's in. So this is in this box, these are in this box, this is in this box. And the sum of the digits on the line within each box is the same. So the sum of the two green digits is the same as the sum of the two purple digits, which is the same as the blue digit. And that's it. Those are all the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so this and this, it's the same logic, right? Is equal to the sum of these two and these two. So one thing I want to point out is that means we cannot be roped. And by roped, I mean, actually, no, I think it means we must be roped. Okay, let me just explain what I mean here, because I'm not actually sure which way this goes. So whatever these two digits add up to, like let's say we tried to do 1, 2 to add to 3, right? We could also add to 3 here using 1, 2. But then this would need to be a 3. And now this cell would need to be both 1 and 2. We wouldn't have enough place to put 1 and 2 in this box. So that doesn't work. So what I'm saying is that we need different digits here. And those different digits need to sum to the same amount as these two. So they need to be two completely different. It has to be two different digits that add to the same as this, right? So we need two ways of adding to it. So our options are either to add to 5, because we could do 1, 4, and 2, 3, or swapped, or we could add to 6, because we could do 1, 5, and 2, 4. But that means that these digits are different than these digits. So I could actually color them and say, hey, these digits are different than this one, which is also different than this one, which is going to be 5 or 6. And so now so that does actually cause roping, because now we ask where in this box the green goes, and both green digits must go here. And if we call this digit blue, that means the blue digits have to go here, because that by process of elimination. But now purple in this box has to go here, and purple in this box goes here, and then the greens go here and here. So that we call, oops, not the green here. This is the, sorry, this is the blue. And so we call that roping because it's kind of like a braid, or like a rope is like twisted around, right? 6x6s are always roped horizontally, but that's less interesting than being roped vertically because there's 3 boxes involved vertically. So what does that mean? That means that we always have a 1 and a 2 split up between these, but we don't know which is which. So we can do the same logic over here. Now I'm going to use different colors because I don't know that they're the same digits, but we can just say yellow's here, and it's not here or here, so yellow goes here and here. And then we can give this an orange color, which then goes here and here, and then we can give this a red color, which goes there and there. Okay, so we don't know that these are the same digits, but okay, so here's something that we do know. We know that these two digits add up to one of the green digits, which goes on this line that adds to 5 or 6. So this can only be, naively, because it's not going to be 5 or 6, because you can't put 5 or 6 here or here. No, we could put 5 here or here. It can't be 6, though. Ooh, it could be 5, though. But naively, it's 1, 2, 3, 4, 5, but it is the sum of two different digits, so it can't be 1 or 2. So this is a 3, 4, or 5, which then also is part of this sum. Now we know that both sums always have a 1 or a 2, because we're going to either be 1, if we add to 5, we're 1, 4, or 2, 3. If we add to 6, we're 1, 5, or 2, 4. So a 1 or 2 is always involved. So this is the green 1, 2 right here. This is also 5, 6, by the way. So we get a 5, 6 pair here. Okay, yeah. Unfortunately, green and purple can have 5s in them. So I'm not sure. Like, otherwise I could limit this to be a 5, 6 pair, like right away. We do know the 6 is involved here and here. We do know that. Because green and these colors can't have 6s at all. Okay. There's something about this line that I need to understand then. So over here, we definitely need, again, red needs a 1 or a 2, and orange needs the other 1 or 2. Now, this sum here also needs a 1 or a 2 because it adds to at most 5. In fact, if it adds to 3 or 4, it needs a 1 specifically. If it adds to 3, it has both. So there's a 1 or a 2 involved in this sum. And there's a 1 or a 2 involved in the yellow. Oh, right. Sorry, orange is the larger ones. In fact, we know what the... sorry. Let's just do this one thing at a time. So over here, it's the red and the yellow that must have the 1 and the 2 in it, one each. But we know that this red is going to be the one that's 1 or 2. And then this actually, this is where I want to talk about what these are limited to, because green and purple are either going to be, let's write it out, 1, 4 with 2, 3, or they're going to be, so if they were 1, 4 with 2, 3, that adds to 5. This would be 5 and this would be 6. So in this case, it would be exactly 5, 6 like this. Or these could be swapped, right? But that doesn't matter. If these were 1, 5 with 2, 4, then we would add a 6, putting a 6 here. That makes that the 5 or 6. But the other missing digit is a 3. So those are our only two options here, is that this has to be a 3, 6. And there's always a 6 involved. And these are going to be different, right? Because this is a 5, 6 pair. So there's going to be a 3 involved in one of these two cells. Right? Because I mean, I guess we know that from the 3, 6 pair, right? But just thought I'd point that out. So this is limited to only 3, 5, 6, but it's obviously not a 6 because we can't add to 5. We can't be a 5 either, actually, because 5 plus 1 is already 6, and this cannot be a 6. So the conclusion is this is a 3, which means orange has the 3, which means we're 3 and 6 here, which means we're 5 and 6 here. Remember, because 3 and 6 went together and 5 and 6 went together. And so now this is not a 5. So it's either 3 plus 1. Oh no, it has to be 3 plus 1 is 4 now. Wow, okay. So green has a 4 in it. Right, this is the ones that add to 5. And green has a 4 in it. So it's 1, 4, and we know the order because of that 1. This is a 1, 4 pair, and this is a 1. This is neat. And so now these are all the 2, 3 pairs. Oops, did not mean to do that. And we know that this is the 2 and the 3. And these are, of course, the 5, 6 pairs, because blue is 5, 6. This is 2, 3 here, because of this 3. Nice. And so now this, because they add to 6, this is our 1, 5, giving us, resolving that. All of these are 1, 5, in fact. Resolves this 2, and that, and that, and that. And then this is our 6. This is 3, 6, which goes in that order. And then the remaining, that gives 2, 3. And the remaining digits are the 2, 4. So we should be able to just plonk those. 2, 4, 2, 4, 2, 4. And we're done. Wow, that was neat. Took a little bit of thinking about exactly what was going on with these and the roping. But yeah, that was a really cool use of that. So thank you, ZegreS. Really enjoyed that puzzle. Had to use my noggin a bit. And that's always great. Let me know how you did on this as well, how you felt about it. If you enjoyed it, then why not leave a like, subscribe, and a kind comment below.